Well, hi, good morning, and thanks so much for joining me here in my shop. Today is September 11th. So I was getting ready to do the alignment over again, only using a more powerful approach, using a sweep generator and things like that. When I looked into the schematic and said to myself, there's some fantastic information here I'm not really making the best use of, and that's all the tube voltages that are listed very carefully in the schematic on a nice diagram. So I think I'm going to utilize that. I'm going to forsake doing the sweep alignment today, and I'm just going to focus on taking voltage checks in the radio around each tube base basically, and see if they don't match what shows up on the schematic. So I just finished arranging everything kind of for the sweep alignment, but I'm going to rearrange things now so we can do this voltage check. Okay, I think I'm ready to go. So on the right is the chart of voltages, and I'll be able to zoom in on that, I hope. In the center, of course, the radio, and on the left is the meter we'll be doing the measurements with. And the meter should be on 0 right now. Okay, let me start up the radio. Break a few things in the process of doing that. Now, the one thing I didn't really make a great allowance for here in the positioning of things was me. It's going to be a little awkward for me to work this, but make sure the radio. Now, so we're likely to hear nothing out of this radio because I have the antenna shorted as per the instructions. I think we'd hear something. Still warming up. And they want the volume set to full. The supply voltage 122 volts. And the next thing I'm going to do is I'm going to try to zoom in on the rectifier here. So bear with me, it's a little awkward for me at this end. Rectifier, eh? Because I got this whole thing set up and then realized that everywhere I look it's too small for me to read the voltages. Here we go. It's not too small now. (760 volts RMS between pins 2 and 4 of the rectifier tube. So to make that measurement, I would not want to use my my VTVM because we're not reading to the chassis here, and it makes me nervous. And plus, that's a really high voltage. Holy smokes! So we're going to use this meter here. I just got to prop it like this. Okay, now the diagram is angled exactly the same as the tube, supposedly, but let's verify that. I'm looking for the tube key. It's in exactly the same position, so the diagram is positionally accurate. So if we want to pick off 2 and 4, I think 2 would be this one. Okay, and 4 would be the one after 3. Set this. I got it's on DC. Duh. Oh my gosh, I'm 750 volts maximum, and we're going for 760 volts. Let's see what happens here. Something funny about my meter. It's the first time I've ever made a measurement. 750 volt AC scale here. Time to do some work on the meter here. Even my new meter has become old in this shop. I don't know, let's try it again. Don't slip. Ah. Oh, there's no output from this transformer. Okay, did I get the right pins? How could I get it wrong? How could I get it wrong? 1, 2, 3, and 4. Can't get it wrong. Meter, really? Jeepers creepers. Another one here. I don't know what the scale limit is on it. Volts AC. It's auto ranging. It's rated at 1,000 volts for the probes. I don't know. How disappointing is this already? And I shouldn't even bother reading this particular voltage too. And we'll give it a go. Okay, once again, we're on volts AC. It's liable to beep. This thing has a safety beep. It beeps when voltages above a certain amount are detected to warn you that you're touching something high. What are we supposed to make of that? 0.9 volts. What's going on? Have I got this totally backwards? No. No, it can't be. Come on, it can't be totally backwards. It can be partially backwards. 760 volts RMS. Between 2 and 4, where the output wires from the transformer are coming. You know what? There's nothing on pin 2. There's nothing on pin 2 here. It's an empty pin. What? Yeah, that's right. I'm speechless. Something that doesn't happen an awful lot. What is going on? Okay, let me make a more firm determination as to where the key is. The key bump on there. I think it's right here. Definitely, it's right there. That makes that 1. That makes this pin 2. Pin 2 not connected. Pin 2, 5Y4G, pin 2. So this is top viewed. This is looking down from the top. That would make, and not, but they've numbered them. Pins 1, 2, 3, and 4. They numbered them. That's definitely 2. Holy cripe! Come on. Well, it's the other way around. We would find this pin and the next pin. There's no connection. What the heck am I doing here? What is going on? What is going on? I drank my coffee. I ate a nice breakfast again this morning. A little light on the bacon. Usually have 1 piece of bacon every morning. And my piece was pretty skimpy. Is that the reason? Well, if we count the other way, just count backwards, then we would see 1, 2, and 4. It doesn't make any sense. This doesn't make any. Oh my God! I'm stuck on the first 2, and the radio works. What in heaven's name? Well, let's just take a different approach here. So, ignoring this big wire, we can see these 2 wires and these 2 wires. These 2 are the same color, these 2 are the same color. 2 of these are heater wires at 5 volts, and the other 2 are the 2 plate wires with the 750. It's supposed to be this and this. Is it just that I'm just so stupid I can't count? 1, 2. Well, if we take 3, 4, and 5, 3 and 5 have something on them. Okay, now we get back to the problem of the meter. This is even within the range of the meter. Okay, well let's test things with wires on them. That might make more sense. As for what? Oh, son of a gun! Scared the living. Damn it! Why would that be so noisy? I'm either touching the heater or I'm touching the plate. Why so noisy? It's just this little voltmeter here going nowhere. Because I got the volume cranked up full. That's why. Let's just crank it down a little bit here. My poor meter's saying it's overloaded already. You know what? I need a different meter. I'm just worried that this meter is no good at this high voltage. And it's probably okay. It's a question of gambling. Don't feel like it right now. I have alternatives. How about this one? How about this? This is the one I usually do car work with. 750 volts. Let's try it. 750 volts AC. So the battery's good on this. Yeah. Oh, for crying out loud. We're not getting anywhere here. I have another meter. Oh, for crying out loud. Yeah, I'm crying out loud, alright. I don't dare use this meter because the meter is case grounded to the power system, and I'm putting it in there, yikes. It just scares me all to heck. Okay. Can't read a voltage here. What did we skip that? Skip that. You're trying to find, so there's a DC voltage written there, 300 volts to ground off of pin number 7. If you get 300 volts there, then there has to be 760 in the other spot, or something appropriate anyway. Okay, let's do that. I'm just going to end this frustration here. I'm very sorry about that, but I do try to make these videos as live as possible. So sometimes things don't work out all that well. I just have to just move on. Okay, we need to hook up this meter too. Disconnected completely. Okay, ground connection. Just always nervous when I do that, and if you watched a few videos ago, you know why I'm always nervous when I do that. So now we want to pick up. So this is 1500 volts now. Boy, this meter can take the voltage. 1500 volts. And what we're only expecting, we're not expecting anywhere near that. We're expecting 300, not 700. 300 on pin number, hey, I'm going to actually make a measurement here. Pin number 7, which comes just before 8. 7. This be 7 here. And there goes the meter. So 330. Wow, this has got extra. It's extra good. Wow, that was a lot of nonsense for one test on one tube, wasn't it? Yeah, okay. Okay, now on to the next tube already. I'm just going to expand and increase this a little bit here. Make it just a wee bit easier to see. Good. So one of the 6F6, which are now 6 V6s in here. Okay, let's see if I can keep my head on this time. Starting down here, pin number 1. Pin number 1 is actually nothing. There's nothing. There's a Well, there's a ground connection made to it. But there's no pin. The actual pin is omitted here on both 6V6s. There's no pin in this slot. This one, they have a wire going to ground. Nothing else. The other one, they bent back this tab and soldered it right to the chassis. I have 2 glass tubes in there right now, which is probably why these pins are vacant. Now you put 2, I don't know, do they come in metal case cans? 6F6s do. 6F6s come in a metal can tube. And that's probably the shield. Okay, onward. Figure that out. Next one, pin 2, looking at the chart. AC, we'll skip skipping that. Skip that AC thing. Next one, pin 3, plate. One, 2, 3. Plate voltage is supposed to be 240 volts, and come on, man, keep the pointer in the spot. I'm reading on my meter they're 230. Well, that's really close. The next pin should be a little higher than that one. So I'm looking at the meter there. 230. Next one, 200 and just under 50. So a little bit higher, exactly as shown. Next one, 0, blank, ground. That's it for this tube, in fact. That's all there is to it. Okay, now we'll go up to the next one. Should be pretty easy to do. Pin 1, 2. What was pin 2? Is a heater. Pin 3 is 240. Pin 3, all this stuff on it here. So, that's interesting. Now, these tubes, one was hot, one was not. This tube's 190. Let's go to the other one. 240 correct. 190 not correct. That's interesting. I might not get too much further than find an anomaly like this and then go off and hunt down why it might be, rather than test all the tubes and put too much in my head at once. So we got 240 here, and then we're supposed to find not 240. We got 180. We got low here, but then here we should have. So there's full there. So it's just here that it's testing a little low. I left that old capacitor there. How could that possibly upset this? This is just running between. So these two connections, these two terminals on these two output tubes, a wire runs to the outside terminals on the center tap primary of the output transformer. So if there's a variation in the voltage that's reaching the tube, there can only be a couple of reasons. One is something's wrong with the output transformer and it's unbalanced now. Maybe some windings shorted, which is very unlikely. Another one is there's a variation in the tubes. That's possible. And that's causing a varied current through the tubes. I shouldn't really pull down the screen or the plate voltage. So the screen is usually supported by a resistor, or there's a resistor in series with the screen circuits, and in a push-pull it could be one resistor. It could be this guy right here. One resistor can't be behaving two ways. Is that really that resistor? I'm not even sure that that's really the case. So I don't think that's what that is. So there may be maybe two screen resistors in here, and one of them is varied from the other. When I look at the diagram here, oh, I got it kind of backwards. The plate should be the lower voltage. The screen, so the two screens are testing correct at 240 in fact. Let me try this again, now that I've realized that I kind of had it backwards in my head. the plate. The plate is this one. This is the plate. 1, 2, 3. Plate 230. Plate 190. Screen 245. Screen 245. So the screens are identical. I think there's a wire running straight between. They can't be anything but identical. The plates, in a sense, have a wire running between them, but it's the primary of the output transformer. I got to this point last time, and I was going to swap the tubes, and then I discovered the tubes were messed up, and I popped in two 6v6s. We're in a position again where I can swap the tubes and see if this problem travels with the swapping. So let me just get it really straight in my head. The lower tube has the lower voltage. Is that correct? 1, 2, 3. Plates both 240, right? Right. No. Well, I'm just totally confused myself here. Sooner or later I'm going to put a short in here too. 240 screen. Doesn't take much to confuse me these days. So those screens are fine. It's the plates that are different. The lower tube right now has the higher voltage. That's 230, 180. Okay, we're going to switch the tubes. The lower voltage is the upper tube. The lower voltage is the upper tube. One more time. The lower voltage is the upper tube. These will be hot tubes. Hot tubes. Here. Out you come. Wow! At least one of them is really hot. Wow, that really cooked up. That was the upper one. The upper one. Oh, both hot as can be. Now, don't get them confused and put them in the same place. Oh man, I can't hold on to it. Let's try this one. She's a hot one. Usually I go away and wait a while. Okay, got that one in. You can't see all the funny action over here. Get in there. Come on, man. There it goes. Okay. Okay, I definitely swapped the tubes. I did it correctly. Whew. There's a bit of a hot deal there. Okay, we'll turn this guy back on. Lower voltage at the top. What the heck was that? So on the bottom of the bottom plate, 220, climbing just a wee bit. Lower in the top still. Lower in the top. So the problem is not the tubes, the problem is in the circuits. How can that be? Grid voltage not the same. Grid bias not the same. Okay, can we? Well, we can. As long as we measure both of them exactly the same instruments, we'll get a comparable result, even if it's not true. So look at that chart, and who says? So the grid is at 0 volts, of course. Yeah, there's no grid voltage here. What am I talking about? These are cathode. This is a cathode biased with a single resistor. A variation in the heaters. The No, how could that be? Because I moved the tubes. The problem would be in the tube if it's a heater problem, and one tube's actually much hotter than the other. And moving them would have moved the problem, but it didn't move the problem. What is the chance that the heater voltage is incorrect? Let's see if we can measure it. So I believe one heater is grounded. Yeah, I can see it on the diagram there. The other heater is pin 2. Hey, pin 2, isn't that a familiar pin for me? I enjoy the pin 2. Pin 2 on the first guy here, and we're measuring AC volts, 15 volt scale, and we're looking for pin number 2 on the correct tube. Okay, 1, 2. So there we see a reading. Let me change this to 5 volts. What do we get? Should go right over, shouldn't it? Oh. Well, we're getting like 2.5 volts. Okay, and the other one, 1, 2, right here. Oh my God! Well, no, that's 2.5 again. What am I doing wrong here? Oh, I know what I'm doing wrong. I gotta flip this onto AC. Yeah. Add a resistor in there for the DC measurement. Okay, AC measurement on 2. Now that's more like it. Actual measurement, real McCoy measurement coming down. 6.2, you know, that could be 6.3 for all I care. It's just barely above 6. And we come down here. Just a second, I decided to drop everything here. Two. Exactly the same voltage. So, I mean, really, how could it be much different? So you have the same heater voltage, we have the same screen voltage, we have different plate voltage, we have a couple of old capacitors sitting there. So this capacitor goes to ground, but this one is between the plates. They're doing entirely different things. Can this guy drag down the plate voltage? You know, to do something like that, it has to draw a fair bit of current, and it would get hot or warmer. So let's say if this guy's causing a problem, it would pull this side down. Oh, that's not what I want to do. That's definitely not what I want to do. It would pull down the side it's hooked up to. Well, this must be the corollary. So I replaced the one that went from here to here. Corollary is not the right word, but I think you know what I'm getting at. Oh, I got this on negative here. Okay, what are you? You are 250. And what are you? You're the low one. So the low one is the other one. Wow. How could this possibly cause a variation between the two? One side, 250, other side. I mean, how can it do it? 40 volts difference. 40 volts difference. We have to break away and look at the schematic. We must look upon the schematic at this point. What a schmozzle when I go to change all this. Okay, you know, maybe I can get the schematic right on here if I'm really clever. Let's see, how clever is he? There it is. Okay, there's a piece of it anyway. Now, I think I can move this around if I do this. I can swing this guy around right in front. Okay, so let's look at the output tubes here. What is it about these that you could have a variation in the plate voltage. So here's the capacitor between them, and then here's a capacitor to ground, and here's another one to ground. They're both 0.05. They're both doing the same thing. I replaced one of these, and this one look the same. This is a 0.05, 0.05, this is a 0.01 here. They look the same. Can I read the sizes? I'm trying to read the sizes on them. I can't see the sizes. They're installed so the sizes are hidden from view. So how do you get a different voltage here when this is the only thing that's involved? Because you have this, and this is the screen. You can see there's a solid wire. That's why we get exactly the same voltage on both of them, screen-wise. But plate-wise, the only thing, the only thing I can conclude is there's some problem with the output transformer, and I can't overcome it. Because again, like if one of these, if this was a leaking enough to pull the voltage down, I would think this would get pretty darn hot. Is it getting hot? Is it getting hot? Let's see. I can't, I'd have to get my viewer in here to really, I can't say I've ever felt a capacitor get hot. No wonder. It's not fun doing this. So everything's a little bit warm, but it's exactly the same temperature. I can't imagine a capacitor getting hot. How about this one? Now this one should not get warm, or this one. So they're all just kind of warming up because the radio's warm. And that would be, that's the explanation for the two different temperatures of the tubes. Let's see, which one's hotter than which? Which one's hotter than which? Okay, I'm just going to use this measuring guy here. Just take a shot at it. 108, 118, let me just try it again. 162, 93. Well, there's a clear difference. So the 162 is the upper one. Let me shoot the base here. Now, I mean, this thing is taking an average of everything it sees. It has a little diagram on it. See, the farther away you go, the more it sees, the more it averages. So this is not the easiest. Okay, nothing here to get. 48, 48, 24, 45, 48. Not much difference in the tube base. 113. Both of them reading 113 like that. So what can happen when I'm doing this is the both measuring the same now. What am I doing here? This is crazy. Let's put that away. The when you're using the infrared viewer, if the heater comes into view of the viewer, then you're going to get a really high reading because the heater, of course, is extremely hot, and even though it may be a small portion of what you're viewing, it's going to push the reading way off. So how else can I tell quickly which is which? Can't. Gotta go get my my thermal viewer here. Okay, just be kind enough to ignore what's on the right side of the screen here. I'm just too lazy to reset all the video settings to get rid of that. So we're set now for 30. Red means 30 or above. Red means 30 or above. We don't want that. We want to select the top temperature and raise it way up. Now something has to be quite hot to be red. Okay, so now we're up at 85 degrees. It was a little bit lower than 85 degrees. You'll start seeing red on the screen here, if you can see it. It's very, very tricky to get this visible on a camera. I I think more light in the room will help desensitize the camera a little bit. Okay, we can see stuff. What are we seeing? So, put it this way here. So we're looking at the last 4 tubes in the radio. See that? Rectifier, output, output, and this one is just one of the regular tubes here. It's this one here. And we're looking up at the tubes in a way in which, let's see, I'm looking for my own eyes, you cannot see the heating element directly. So I'm going to raise the red level, if you like, I can put it that way, until something disappears. So you see the center tube is disappearing from view. The center tube is one of the output tubes. It's the lower output tube. The upper one remains hot. Is it because of angle? No. You see that? You can, oh good, you can still see it nicely. The rectifier tube and one output tube are about the same temperature. That temperature is 195, almost 200 degrees C. It'd burn the skin off your finger if you touch it. Now, what exactly is that hot? The glass tube? The stuff inside? Judging from what I can see in the viewer, it's the stuff inside. So the glass tube, if I trust this machine, I can't tell. There's a way I can tell. Just move it very carefully like this. Maybe 100 degrees. Maybe 100. Maybe, I don't think I can trust this, 150. I can't trust what I'm doing. I'm not going to find out anyway. So clearly, this tube is cooler than that tube. The upper tube is the lower voltage tube, isn't it? Isn't that what we discovered? The upper tube is the lower voltage. So 200, 250. Lower voltage makes it hotter. The lower plate voltage makes the tube hotter. The lower this is so counterintuitive. 250, 200. The lower plate voltage makes, oh, wait a minute. Wait a minute. I got this wrong. Don't I? No, I don't. The lower plate voltage makes this tube hotter. Wow, that's just totally... And then if you swap the tubes, it doesn't change. Let's swap the tubes again. Oh yeah, I'm gonna stop and let them cool off this time. I don't want to do more tube juggling. Like, man, I could do that on stage, right? Come out with some hot vacuum tubes and juggle them. It's exciting because if you drop one, they smash, right? Juggling. Okay, so I went off to find some juggling balls, and I was going to tell a story about them. I couldn't find the juggling balls, but instead I found some photographs of me way years ago when I was working, and I'm just going to show them to you. Not that I want my videos to be about me, but if you've watched lots and lots of my videos, then you might be a little more curious about me. This is about 1982. That's me there in the red jacket, obviously, and those pits are fire pits because I'm on strike. I was in the union at this time. I hadn't yet joined management of the company. There's another picture. That's me in the middle on strike on Toronto Hydro. So yeah, about 2 weeks after this strike ended, I was promoted into management. Here I am in a three-dimensional photograph. This is taken with a 3D camera, something quite new on the scene back then. And I purchased this camera. My intention was to take manhole photographs in 3 dimensions. Never got anywhere with it, but I'm the kind of guy who tries these things. So if you were to cross your eyes, that would become 3-dimensional. Don't do it. This is me in a safety meeting, and I'm training my staff. That's my staff all around those tables, and a couple other supervisors at the head table there. And what I'm demonstrating is how to open up a manhole lid. I've got the pick in my hand, and I'm explaining the moments where you get injured when you're doing this process. And everyone's falling asleep watching me. In my last picture, that's me in the tie. That's not my boss. I'm the boss. That's my assistant. The two of us are the corrosion crew for Toronto Hydro, and our job is to try to control stray DC currents from the Toronto transit system, the streetcar and subway system. The stray DC currents cause corrosion of underground cables. If you look on my desk, I've got 2 ground rods there. One, the bottom of it is gone, and the other one has necked just where it would be popping out of the ground. It's necked down. It's ready to break. And then right in front of me, I'm pointing at it, is a large piece of cable. That's copper, but you can't really tell in the picture now. It's faded. It's green, and that came out of a manhole where I kicked the cable and my foot went right through it, because the whole thing it looked like a copper cable with a bit of patina on it, but in fact the whole thing had turned to powder. I just put my foot right through it. Brought this piece up to show, and my assistant and I there, we are pretending to talk about okay, I'm going back down memory lane here. We're pretending to talk about the corrosion problem there for the photograph. Okay, I apologize for doing that, but that was me way back then. My section had a $6 million a year budget to spend. Not on corrosion, but on other things that I was also involved in. So I had to figure out a way to spend $6 million a year on a hydro system. That's not as easy as you might think. But I did it. Okay. These got to be cool by now, eh? Yep. Now, why am I even doing this again? I want to be absolutely sure. I think that's why I'm doing it again. Okay, switch on. Bit of residual heat in them. Obviously it's going to take a little while, isn't it? The rectifier appears hotter than the... you can already see a difference. The middle tube is cooler already. So we're having the very same effect. That white dot you see jumping around on the screen, that's marking the lowest temperature pixel in the image. And then it's reporting it. There's also a red dot jumping around, but I don't think the camera's picking it up. The red dot is actually sitting on top of here, and that's marking the highest temperature pixel. Those two temperatures are reported down here. So I can see the hottest thing on the screen is 125, and the coolest is 23 degrees. So you know, we're getting the same result here. Hot on top, cooler in the middle. How come it doesn't seem as dramatic this time? I think we just have to let this sit here and warm up for quite a while. The heat will build up. Things will eventually turn red. Where am I going to go with this thing? What am I going to do about this? What can you do about it? You can't do anything about it, really. I guess, you know, on a long shot I could replace these 2 capacitors and see what happens. Why not? Why don't I do that? The heck with an alignment today. Oh, heck with even reading voltages. I'll change these 2 capacitors. Just see if it makes a difference. That may raise some pretty interesting questions if it does. Okay, so it turns out both of these capacitors are 0.05s. One of them is supposed to be a 0.01. That's quite a difference, 0.01, 0.05. So you had a 0.05 between the plates when they should have had a 0.01 rather, and that's what's here now. So you get the two 0.05s going to ground off of each plate, and this in between. Why don't we test these? I'm willing to bet these capacitors are okay. But since nobody can collect on my bets, it doesn't take much for me to want to gamble here. So I don't know which is which now. $50 volts. What does the eye do? Right open. 150. Right open. 600 volt capacitor. 250. Still opening. So, you know, these are not bad. Wrong size though, and something else. When I started removing one of them, the terminal and all the wires connected to it and that just kind of fell apart. The soldering wasn't good. A combination of my soldering and the predecessor soldering, because it's a very messy connection. 50 volts, what do you do? Same as the other one, I'm sure. Yeah, there's really nothing wrong with these, except the wrong size. Put that there, don't touch it. Could be 100 volts on that capacitor. Now, what is going to happen this time? My prediction is exactly the same. That's my prediction. Okay, radio on. Dim bulbs show okay, everything normal. Full on. Now we're going to find out if somehow those capacitors were implicated, or maybe this connection. This is the connection that was busy. Hey, what's on it already? Come on, hold on there. Okay, so now we're reading the full voltage to the radio. Since it's operating, okay, 215. The same basic difference there. 215 versus 250. The only conclusion I can reach is the output transformer is not uniform, and there's nothing you can do about it. And I've never encountered that before, but then I've never ever poked so deeply into one of these situations. So what about it? So I think I just have to ignore it. Such a dramatic temperature difference. So I'm gonna move on. We'll just leave that. In fact, I think this is the end of today's effort, because I can see by the clock up there it's getting towards lunchtime. So I think I'll leave it at that. Poked into that pretty deeply, but what can I do? I don't know. Thanks a lot for watching, and I'm just going to continue on with these voltage tests tomorrow, and then eventually we'll get back to alignment, assuming everything works out. Thanks.